Hi, welcome and thanks for joining us for this week's Tuva weekly webinar. We're going to be talking about using Tuva to make middle school and high school math more authentic, relevant, and engaging for students. So let's dive in. So first, right, we just want to kind of big picture, where are we going, right? What is Tuva? It's this awesome math and science instructional program for students in grades 3 through 12 that brings this real world, authentic, engaging learning into our everyday instruction by using data. So, right, that's what Tuva is, and we're here to talk about how can we leverage it better in our math instruction. So today we'll be talking about, we'll sort of kick things off with a thinking prompt about our own practice. We'll look at the big picture of what Tuva provides for math instruction. We'll demonstrate a couple sort of key concepts that students often really struggle with in math in middle school and high school, and how Tuva helps us, how the tools that are specifically designed help us leverage these real world data to get at those concepts, to build their conceptual understanding. We'll talk about some resources Tuva has to help get you started, and then think about some next steps. So as we dive in, I think it's important if we all sort of take a moment and pause, right? There's a lot that we're working on. So I suggest these 3 different questions. And so pause the video, take a look and think for yourself. So what mathematical concepts do your students struggle with the most? What mathematical concepts are the hardest to teach that sort of you haven't quite found the right thing yet to work on? And what strategies are you using now to make math more relevant and engaging for your learners? So what does Tuva bring to math, right? So through the program that Tuva offers, it helps promote conceptual understanding of these really tricky math concepts that are traditionally hard for students to understand. And the tools have been specifically designed and fundamentally designed to enhance this conceptual understanding of data, modeling, and other math concepts that oftentimes are sort of tricky for our students to really wrap their heads around, besides just execute the equations of. So let's dive in to think about, kind of at a big picture, what Tuva provides at different grade levels based on our students' math understanding and what they're working on. So we can really leverage Tuva to get at these distributions of data, this big thing that we're working on in middle school. And we can help our students build their understanding, a deeper understanding of variability, central tendency, the impact of outliers on a data set and those summary statistics of the data set. And also we can construct bivariate plots in ways that better contextualize the association between those 2 quantities. And so more than just physically making the graph and seeing it, sort of being able to engage can help students build that contextual understanding, and then creating functions to model relationships, be them linear or sort of, as we're starting to understand, those non-linear relationships that exist. When we move up to the high school level, we continue building on that understanding of distributions, right? And we can dive more into the shape and the center and the spread. And by using a wide range of real world data sets that have the natural variation and differences in these distributions, we can sort of leverage the real world data to get at these concepts. We can also construct models to better contextualize, building off of that linear and nonlinear relationships, as well as utilizing the summary statistics, right? Calculating them, but then also, what do they provide for us? How can we leverage these to make better predictions moving forward with a data set, sort of, so that it's not a one and done execution, but really leveraging those summary statistics for all they provide. As well as we're moving into the statistics, sort of more statistics, visualizing those key concepts of variability, distribution shapes, patterns of association, central limit theorem, random sampling, with or without replacement, right? These are all different things that are baked into the tools and features within Tuva that we can be leveraging as we go, which is, right, all to help build our students' understanding contextualize it in making predictions and drawing conclusions from the context of the data, right? So when we have that real world data that Tuva provides, there's a purpose, there's sort of a reason for why we're having our students apply all these different math concepts as we move forward. So that's the kind of big picture, overarching, how can we leverage Tuva? And what I think can be really helpful is if we dive in and look at some specific data sets to think about how we can really build on the tools that Tuva has with their data sets. So one moment. And I'm going to move to a different screen. So we're going to look at a couple different data sets. This first data set we're looking at is of land animals, a fun data set. And so it's got a variety of different information about a range of different animals, 30 different land animals that we have. And so we're coming in, we can look at the data. I'm just going to open that up so we have more space to look at the actual data. And so if we're interested in, say, the body length, comparing the body length of these 30 different land animals that we have. So we can plot it, we can do some of those initial summary statistics that we teach, that we start to get our students teaching and learning about in middle school. So we've got our mean, and we can label that up. We can add our median in as we're helping our students see the difference between mean and median. So right away, right, there's what is this and how does it relate to where the data actually are? We can change up the graph type that we have. So now we have a sense of what our mean is, what our median is of the data, and then we've got it in this box plot for our 5-point summary of the data with the actual data points that we have of the data set. And so now we can start conceptually understanding, how do all of these different pieces fit together, as where, yes, we learn how to calculate them, but what does that actually mean for a data set? And within this data set, right, we can also look at, these 2 data points out here seem, they're really far out. These are some outliers. And what we can do is we can highlight those, we can exclude those cases, and then we can in real time see how that shifts these summary statistics that we have about our data set. So we can get a sense, like by visually seeing, what that mean and median means and how it's influenced by outliers and other things that are going on in our data set. Another one I want to show you is with M&Ms, because Halloween's coming, and right, who doesn't love M&Ms? So these were data collected from 816 actual M&Ms, which is just lots of fun. I wish I had been able to collect it, though I probably would have eaten many of the M&Ms. So let's say we're interested in exploring looking at our bivariate data and constructing plots to look at bivariate data. So we can look at the diameter of these M&Ms as it relates to the mass of the M&Ms within this data set. They're 816 points, so it takes a little while to respond and all load. And just some initial looking, we could look and see like, we sort of have 3 different clusters going on within this data set. Now, what we're really interested in is looking at these, those 2 relationships. So I'm actually going to clear out. The data set has 3 different types of M&Ms. So peanut butter, and plain. And I'm just interested in looking at plain M&Ms for the moment. So filtering out those 2 other categories of types of M&Ms, and we've got it. So now we're just looking at plain M&Ms and trying to figure out, so what is this relationship, right? And one of the great things that we can do within Tuva is that we can add a movable line, and then our students can move this around to get a sense of what do they think is the best fit of these data. How do these data relate to each other? If we're having trouble, we want to make this pop out a little bit more so they can play around and move the line to get a sense of what is this positive relationship. And what's nice is that if they scroll, when we scroll over the line, right, we can see our equation of y equals mx plus b. So by tinkering and moving around, we can make a prediction of what we think is the best fit line. And then we can look and see how our prediction did with relation to the actual best fit line of the data. So we can plot the least squares line. And again, we can go in and we can see, okay, this is the line fit of our data and the equation based on that. And we can compare this equation with the original prediction that we made. And then we can get at the like, oh, why are they different? Why do they differ? What does that mean in terms of what we were seeing in the data and what we can understand about the data, different things like that. Now, if you're interested and you want to move forward with this, right, you could extend it and you could see how do those relationships vary when we have different category types. And rather than just adding one line, so this is the line of fit for all of the data, we could also add the least squares line for our different categories. Let's see how this goes for us.
Into color. Okay, yeah.
So now what we have are, we've got our least squares line for our, let me just extend this legend so we can read it better, for our peanut M&Ms, for our peanut butter M&Ms, and for our plain M&Ms. And there's a lot going on in the screen, but it also means there's a lot that we can dive into and explore more, like what's going on in those relationships and what do these lines mean and what do they tell us about the relationship. That's sort of what conclusions can we draw within the context of the data. So we've looked at our land animals example to look at those summary statistics that we so often teach and giving kids that in real time sense of how those vary and why we calculate those summary statistics. We can play around and explore the data to get a better sense of what these relationships are. But these are linear relationships. And so another thing that I wanted to show is we're going to be looking at data of Slinkys. Everyone loves Slinkys. Most kids have played with them before. As a way to think about what if we don't have a linear relationship, and how can we think about leveraging these interactive tools to help our kids gain a better sense of how we fit functions to the data and understand what those are. So here what we're going to look at is number of coils and compare that to the length of the Slinky. And so, visually we can look at this. Some students might, depending on where they are, think that this is linear. But what we can also do, which is really fun, is we can actually model the data and fit the function. And so when we come in here, there's a range of different functions that we can choose from, including our linear relationship. I'm going to go with this one because I don't actually think that it's linear. And we can start playing around. So we can play by moving the slider that is adjusting. Oh, I knocked it off. That is adjusting our function line. So we can kind of play around and we're like, this isn't actually really working. I went off the screen. We can manually add it in and adjust the functions. We're like, okay, that's too low. Still too low. I'm getting frustrated. Oh, I overshot. Let's see about, okay, we're getting closer. And by either using the slider or by manually tinkering with it, we're now giving students that ability to interact as they're building the function to fit the data. So we're applying this concept that we learned, this equation, the algorithm that we learned, but in real time, we're seeing how it responds and reacts and how well it fits the data that we have. So one last thing that I wanted to showcase is we fit our functions, we can look at distributions. One of the other things that I think is really exciting about the features that Tuva offers is that we can dive into more heavy statistics and some sampling. And so I wanted to just quickly give a shout out to how we can leverage these tools to help us gain a better understanding, right? So as we're thinking about sampling and how our sampling statistics, like how our sample influences what we can draw from a population, Tuva has added a sampling component in. And so here we are looking at some data that is skewed data. We can get a sense of what's going on in the data by plotting it up and seeing how it is skewed. So let's sample these data and see how when we take a subset of these data, what happens. So we can come in, we can decide with replacement, without replacement. And I don't actually want 10 data points. I just want a sample size of 50, excuse me. I want a sample size of 10. And so now we can generate different samples of 10 points that are coming from this data set and get a sense of how does it vary from what we were seeing in the whole population, which maybe we don't actually remember. So what we can do is we can add in our population mean and our population interquartile range so that we can have that visual cue of this is what the whole population is. And then here are our different samples as it relates to that full population of the data set. And we can change the size of how many data points we're randomly pulling from the sample, things like that. So the tools that have been specifically developed to get our students actively engaging and interacting with the data can really be leveraged to build out this conceptual understanding that our students have. I think one of the best places to start is when you log into Tuva, you get directed right to, if you click on the content library, we get directed right to the math content filters. So be it by, what grade are you at? What concept are you working on? And we can drill down right away to get a sense of, percent is what I'm working on. And I just, I need an activity that can help me do that. And so really quickly using the filters of the menu structure, we can get a sense of where are we going and how do I get resources that best fit my needs. One thing that I just want to point out, because it's always helpful, is that when you're starting out, Tuva's put together some great quick start guides for math and statistics, as well as alignment guides for illustrative math and the TEAC. So if those are relevant to the curriculum or standards that you're working on, it's a great place to get started. These Man's Best Friend introductory activities have a suite of guided instructional practices for your students as they're getting used to the Tuva interface, but also as they're sort of getting exposed to those math concepts along the way as they're learning how to use those features. And the tutorials as well are great sort of guided step-by-step. How do I get started? How do I get in and start using things to leverage it? So we've got resources on your dashboard, which is where you get directed as soon as you log in, exploring this content library to find activities, data stories, data sets that are relevant, that are all tagged by grade level and by specific concepts, I think is a great way to go. So with that, I think I'm going to open it up for any questions that folks have, and we can move forward from there on what questions are relevant to you and what would you like me to demonstrate some more, or what other questions can we answer?